special edition news report on protein structure.
Proteins are essential to daily life. They help digest food that can be found in your fingernails and even in the tails of fireflies.
The long chains of amino acids will bend and fold through various processes, and their shapes depend on their function.
We have stories on the 4 structures of protein, which include primary, secondary, tertiary, and quaternary.
For tonight's first story, we have the primary structure of proteins. During mRNA translation, codons are converted into amino acids, setting up the primary structure where amino acids link together to form a linear polypeptide. Amino acid monomers include a central carbon atom called the alpha carbon. They bond to hydrogen atoms, amino acids, a carboxyl group, and the R group. Cells use only 20 different types of amino acids to build virtually all the proteins needed to maintain life functions.
The primary structure of protein can be compared to the Boys and Girls Club of America. This club has launched a project to create a bond amongst the kids. Their goal is to form a healthier foundation as they get older. Through the process of making these kids depend on each other, they form a connection that will last a lifetime. However, as children, they are highly vulnerable to outside influences.
So that's kind of like the primary structure of protein.
Yeah, exactly. And it's for this reason that they continue to form bonds so they will be more self-sufficient when they grow up.
Now we'd like to switch over to the secondary structure, which occurs when hydrogen bonds form between atoms in the polypeptide backbone. They create looping coils called alpha helices, which are present in between the oxygen within a carbonyl group and the amino acids group's hydrogen.
Beta-pleated sheets also form during the secondary structure. This is possible when 2 or more strands of a polypeptide are parallel. Hydrogen bonds that form between strands in different planes will result in pleated patterns. The additional bonding increases the protein stability.
The desired amino acid strands to form additional bonds can be compared to a couple in love. To elaborate on this, we've asked Brad Pitt's fiancée to talk with us about their relationship.
So, Kayla, tell me about your relationship with Mr. Pitt. Well, I'm not really sure where to start. We're just naturally drawn to each other. We feel so much more complete when we're together, as if our bonds have been filled, like the missing pieces to a puzzle. Sure, things can get rocky with the celebrity lifestyle. Take that paparazzi, for example. Have you seen those pictures from last weekend?
Wow, you're right, Kayla. Those paparazzi never leave you alone.
You aren't kidding. As I'm sure you could guess, Sharon, it sends our relationship through a helical roller coaster. But when we make up, it's so much more fun to pleat the sheets, if you know what I mean. Kind of the same way they get in the secondary structure of proteins.
Oh, I know all about that kink structure. On that note, let's switch back to Victoria and Sebastian.
The next structure of protein is the tertiary structure, which forms through interactions of the R group and atoms of the peptide backbone, creating a stable 3-dimensional shape.
These bonds are interactions and extremely dependent on the chemical properties of the R group.
For example, hydrogen bonding, hydrophobic interactions, disulfide bridges, ionic bonding, and van der Waals forces.
As stated in a 3-dimensional model of the myoglobin molecule obtained by X-ray analysis, featured in the Nature journal, the tertiary structure of myoglobin is directly related to its function of storing oxygen in muscle cells.
Since the 1950s, when the technology of X-ray analysis was first introduced, 74,000 protein structures have been mapped. This knowledge is essential to understanding the function of these complex proteins.
Good evening, ladies and gentlemen. My name is Sharon, and I will be informing you of the structures for the week. As mentioned previously, the primary structure is simply the arrangement of amino acids in a chain. Following that, we have a secondary structure, which occurs when a sequence of amino acids are held together by hydrogen bonds. Now, the tertiary structure is getting more complex, where the alpha helices and pleated sheets are drawn together, forming a 3-dimensional structure. After these past 2 structures, we have a quaternary structure coming along. Being part of the protein structural organization levels, the 3-dimensional quaternary structure is formed by the assembly of multiple polypeptide chains called subunits. The levels of protein can be described as a ring structure, where the higher levels of structure are built from the structural components of the lower levels. Here we have a hemoglobin molecule. I would like to bring to your attention unstable hemoglobins, which are hemoglobins that, because of the nature of the substitution, deletion, or insertion of amino acids, tend to undergo spontaneous oxidation within the red cell and precipitate to form insoluble inclusions called Heinz bodies. Their presence results in the inherent Heinz body hemolytic anemia. And now, back to Victoria and Sebastian.
And that's all your news for tonight.
Stay classy, Oneonta.